Hello friends, today we'll go to the world of irrational numbers. You are familiar with natural number, whole number, integers, rational number. Now we'll go to the irrational numbers. Irrational numbers, the numbers which are not rational, they are irrational. You know the real numbers, which numbers are real numbers? The real numbers are the union of rational and irrational. And in rational number, you know the set of natural number, whole number, integers, and rational numbers, which can be written in the form p by q, where p and q are integers and q not equal to 0. They are rational numbers. And which numbers are irrational number then? So before you start, we'll see any number when it is written in the form p by q. Say for example 2 by 5, 2 by 3. 2 by 5, when you divide, what you will get? 0.4. So the decimal representation of 2 by 5 is 0.4. When you divide 2 by 3, so it is coming 20 if we write, because it is not divisible. 2 is not divisible by 3, so we are putting decimal, and then it is 6, 18, 2, 0. Again it is coming 6, 18, remainder is 2, and the process is continuing and never ended. So it is 6666, that is it. This type of numbers are called non-terminating but recurring numbers. We'll write this. So non-terminating recurring numbers are also in the form 2 by 3, that is, it is a rational number. So we see the real numbers are divided into two decimal representation. Here it is terminating decimal like 2 by 5, and non-terminating decimal number like 2 by 3. But these non-terminating decimal numbers are also two types. In one type, we see the numbers are not ending, not terminates, but repetition is repeated numbers. Here 3333, but it is in the form p by q. So this is a rational number. But this type of numbers, see 0.31, then 331, 3331. So it follows a pattern. What is the pattern? We are writing a number 3, then 1, then writing the double of 3, then 1. We are writing triple of 3, 1. So it is also not ending, and it is not repeated like the previous one, 333. So this is a new type of number, and it cannot be written in the form p by q. Another number, see 2.25. So 2 we are writing double, then 5 again, then again 2225. Or you see the third number 3.31, 32, 33, 34. So this is follow a pattern. It is also not repeating, and it is not terminating. So this type of numbers are called irrational numbers. So rational numbers can be written in the form p by q, and irrational numbers cannot be written P by Q form. Another form of irrational number, root 4, we can write 2, which is in the form 2 by 1, so this is a rational number. But when you find a root 2, this cannot be expressed in P by Q form. So root 2 is an irrational number. Now, when we take a draw number line, we marked number 1, number 2, number 3. Now, if you draw a perpendicular line above 2, and if you cut off 1 unit, and then if you join, this much is 1 unit, this much is 1 unit. If I write A, this is B, and this is C. So we are getting a triangle ABC. But two sides are of 1 unit. So what will be the length of AC? As we know, AC square according to Pythagoras theorem, AC square is equals to AB square plus BC square. Now what is the value of AB? 1. So 1 square, and BC also 1 square. So 1 square plus 1 square, 1 plus 1 is equals to 2. So square of this, so AC is equals to root 2. Now we can find the position. So this AC is equals to root 2. So now you can, taking this C as the center, and if you take this is the radius, if you draw an arc, so we'll get the position of root 2. After getting the root 2, we can define root 3 also. We look at a point on the number line for root 3. Root 3 is equals to 2, 3, we can break up as 2 plus 1, and then write 2 means root 2 whole square and 1 square. So there are two sides, root 2, already from 0 to this position is root 2. So if you draw another perpendicular line here and cut off 1 unit, and if you join, and if you draw the circle, the arc cuts off the x-axis at this position, and this is the value of root 3. Another way also 1, 1. So this is root 2. And if you draw a perpendicular here, taking 1 unit and cuts off, then this will be root 3. Now take the center and root 2 as the radius. We get the position of root 2. again taking the center and this length as radius, we draw an arc, you get the point of position of root 3. Again perpendicular and join root 4, that is 2. So this way we can find also. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.